Hello everyone, so today we're going to talk about state machines or how to implement them in a microcontroller unit. In this example we're going to use one of the most famous microcontroller, it's Arduino, and we're going to see how we can implement a really simple state machine inside Arduino. If you're actually not sure what is a state machine, you can see over here that we have a LED finite state machine, which actually shows us that it has 4 states and the ways that it can go in. So the LED finite state machine can be on a state on, state off, fade in or fade out, and can actually go from one state to the other as long as the arrow allowing that, or the connection between the states allowing that thing. Why it's finite? Because it can finish actually at each state of the execution. Why we need to use state machines and when we have to use them? Actually, state machines are useful whether or not you have a condition that's not based on time, where you actually have a definition like LED. I want the LED state to be on, to be off, to be fading in or fading out. State machines in microcontroller units are really easy for debugging of the implementation, because you know what's actually happening and where it's actually happening, that thing. Okay, so let's proceed with the implementation. What you need to do is just download the sm.zip. You will find it over here in the website, and you download that thing over there. You put that in the library folder of your Arduino. So let's go into properties. Let's get libraries. Let me show you. So libraries, and from libraries you go to state machines. You have to actually import it over there. And that's the project structure. Example smcpp, sm.header, and state.h. Let's proceed to implementation and what our task. So I want my Arduino to open a serial port. From the serial port, I want to read a string that is coming based on event when that string is filled up. When that string actually is telling me execute or test or start or to whatever command I'm going to expect from it, from the serial monitor, I would like to actually read data from a microphone with an amplifier, and whether or not the amplifier is above some threshold, I would like to light my LED on a pin 13 or the embedded LED pin in Arduino. And when actually I receive a new command, I want to exit from that state and go back to listening for messages in order to switch to third state or go back to the second one, in order to show you how you can actually play with those states. To begin using actually that library, I'm going to include the sm.h we just put in the library folder. After that, I'm going to create a simple state machine that is going to start with a state check if message received. Okay, so let's actually create a state below the loop, and let's name it state check if received. Okay, so let's compile and see if that's fine. If that simple sketch compiled, that means the library is actually set up. As you can see, it's done compiling. You can see it, done compiling. So actually what I want to do is, let's increase my typing to something that you can actually see. Editor font size, let's say 27. Okay, increase it. Yeah, and I can still type. Okay, so now we have one state. We already defined the automator or the final state machine, and now we have to initialize. We said that we want a serial monitor. So let's say serial begin 960. After that, I want to define 2 variables. I want to define that my LED is on pin 13, and that I want to define that my sound sensor is on pin A0 or analog 0. After that, I want to have a string, which is actually width. String, come on, I want a string that is an input string, and here we gonna store the input message coming from the serial monitor, and after that I want a boolean that is going to tell me whether or not the string is completed, and let's say it's false. So far so good. Let's actually say that we want a pin mode of LED to be output, so we can control it as a output pin. And let's actually say that we want for our input string to reserve 100 bytes or characters of the string. So we're telling over here that our input string is going to be less than 200 characters. So the setting is fine. Let's check compiling, and we have a class string has non-member name reserved. Okay, so it's reserve. Okay, yeah, it's reserve. Sorry. Okay. After that, let's go in the whoop, and all we need to do is say execute simple. So we're actually telling to the class execute the state machine I created over here, and the first state is going in is check if message is received. So we have to implement the logic how to check if message came from the serial monitor. What we're gonna do is that each time the string completed, each time that flag is up, we want to print in the serial the input string we received. Okay, and after that we want to actually check if the message is the one that we're expecting. So let's say that if input string dot equals the string execute new line, then just go print that message. After that, make sure that the input string is null again, and make sure that string completed is ready to receive a new message by making it false. After that, if we receive something that's not the message we're expecting, we're just going to make the input string null and empty. It's empty, not null, and we're going to make sure that the state is ready to receive a new message whether or not that message is ready. Okay, so that now sounds like a good plan. Let's continue with the implementation. How are we going to receive the data from the serial monitor? So that's easy. Arduino is actually having a serial event. So all we need to do is set up like this, serial event. And when we have that serial event, each time we write into the console of the serial monitor, Arduino is going to call this method over here, and it's going to execute the body in it. And what we want is, while we have serial.available, okay, we want to get the char, which is in char, which actually cast the char to serial.read, which will read a single byte from the string, or it's going to read each byte of the buffer in the string. And after that, we want to actually say the input string is going to be concatenated with the in char. So actually, if the incoming char is A, the input string will be A. But if after that it's coming B, if it's coming B, the input string is going to be like AB. If it's going a new line, it's going to look like this. And actually what we expect is execute new line. Cool. So after we are actually concatenating the strings, let's actually put an end condition. If the in char that is coming from the console equals the char new line, we can say that our string is completed. String completed equals true. And that's it. Let's first test if it compiles. Nope, input string was not declared in the scope. Input string. Okay, I've got some typos. Okay, so let's compile that to Arduino Uno, and let's actually type to the serial monitor test and make sure that new line is selected, test. It's not something that we expect. We're expecting execute in order to print to the serial console. So let's type execute, and as you can see, we received the execute message. If we received it, that means that this method is called. After that, the state is actually overlapping each milliseconds in the loop and checking for that condition. And let's say if that condition is successful, we want to say after that simple.set check for sound trigger state. So this way we're telling to the machine, you're now in that state, you're actually in that check if message received, but I want you to move to check for sound trigger. And we're creating a new state, check for sound trigger. We're compiling to see if it's working, and the first thing we need to do is to define how are we going to exit from that state, because that's not our initial state. If we actually receive a new message while we're in that state, we have to go back to the check if message received. So if we actually have string completed while in that state, we're going to say to the simple machine to check back in the message state and check that message. If it's important, check and go to other state. For example, we're going to see how this works in the next demo. So let's actually say that while you're in that state, please print line the analog rate of sound sensor. Let's say if that's way. Okay, so sound sensor, and if all is fine, just check if the analog rate of that sound sensor is higher than, let's say, 400. And if it's higher than 400, what you do is digital write the LED to be lightning, to be light up, and if not, we want it to be power down. So let's say whoa. That over here is a magic number. It's good in your code to clean those magic numbers as a definition or like variables. Let's say that we want to define a threshold of 400, higher than the threshold. Okay, let's actually compile. It's compiling, and now it's fine. Okay, so let's actually go and check if everything is fine. So compiling to Arduino, as you can see, it's set. Then uploading, opening the serial monitor, and we're typing test. With test, we receive nothing because the first state machine that is executing, you remember, check if message received, is waiting for execute command. So let's say execute. And when I type execute, you can see that serial numbers are coming, and each time I'm speaking closer to the microphone, something is moving, and my LED, as far as I can say, it's blinking with the same tempo with my voice. Each time the threshold is actually exceeded. You can't actually see that the LED is blinking, but the LED is blinking. On my side, if you're writing it with me, you can check it. But now let's check the exit condition. If we receive a string completed, we have to go back to the other state and stop printing sounds for trigger. Okay, so let's type test. As you can see, at the moment I type test, every single line of the serial data that was reading the analog pin just tapped and came back and check if message received. That message was completed, yes. That message wasn't executed, so clean the message and make it false so we can listen again for another one. And when I come back and say execute, that thing is working fine. It's again in the same state, counting and counting and counting and making numbers. So let me make it easier for you to see actually those numbers. Let's say that we wanna delay of 100 milliseconds or 300 milliseconds each time a message is printed. Okay, so now I type execute, and you can see that the value are going above the threshold several times and so on. Okay, I hope that actually was useful for you, and it's really easy to actually use state machines, defining state, cleaning our code. We can actually make those states in a simple class, which is C++ or C. We can actually extend them or make them bigger by using just one state machine or another state machines. I really encourage you to actually check the examples that are coming with the state machines. You can see concurrent states, or how you can see one state another going when machine have to do something else. You can see that you can execute several state machines to do your work and so on. Just play with them, and keep in mind that it's not the only way to preserve state using millis or any other system that can count time. You can use states to define your behavior or to debug your electronics, so you make sure what's the broken part, what's the working part, and how you can separate them by a nice way so you can actually easy debug and so on. I hope it was useful, and till the next video, bye.